Hey, I'm Ryan with Warner Discovers, and today I'm going to show you how I set up my under cabinet lighting for our kitchen. Now, what we've been dealing with for a while is the ceiling lights, which were just a little too harsh for everyday use. It definitely has its uses here and there, but for every day, we'd definitely rather have under cabinet lighting, especially when we were used to it at our last house. So I wanted to get something integrated for a while now, and I documented my whole process. Now let's take a look at the layout that I'm planning on doing. So as you can see, this is the kitchen over here, and this is the room I'm going to utilize underneath the kitchen. And what we have is a control box that's basically going to power and control the LEDs. So that's going to be in the room below. And then up here we have the kitchen, where we have the left side, which is approximately like 142 inches of length that we're going to be using for LEDs. And then on the right side, approximately 48 inches. So in total, around 200 inches that we're going to be using for LED runs. Now, as you can see here, the highlighted green areas are the areas that are going to be cabinetry that the lights will live under. And everything else I just labeled like the sink, stove, fridge, and cabinet. So what's going to happen is I'm going to have the control box down here that is going to have the power supply and the Zigbee module, and then we'll have basically two runs going out of here for the lights. So we're going to have a 14 gauge wire come up to this point, and then we're going to have another 14 gauge wire come up to this point. So with each one of these breaks, we're going to need a quick disconnect here at the back of the cabinet, and then the LED is going to run, and then another quick disconnect to another LED quick disconnect run over here, and this is going to go back into the wall, another quick disconnect back over the sink, which I actually forgot to highlight, but oh well, another quick disconnect back under this cabinet, another quick disconnect over another one, and then the final one. And then same thing for this side. So quick disconnect, LED strip, quick disconnect back into the wall, 14 gauge wire again, back above the cabinet, another quick disconnect for the final run there. So there's a lot of quick disconnects, and the main concern is voltage drop. So that's why for here we're using 14 gauge wire, and then for behind the stove we're using 14 gauge wire, and the sink when we go back into the wall between those jumps. And then for all the quick disconnects themselves, what I ended up finding out, and I'll elaborate at the end of the video about, is with all the quick disconnects, we need to have 18 gauge quick disconnects because the 22 gauge is not going to cut it. This is the layout that I'm hoping to run, and I'm going to walk through that whole thing with you. And as always, all the links and everything that I'm using are in the description, and I'll go over that at the end. So follow along. I set up all the chapters. You can easily skip forward or back. I know this is a long video, so I understand skipping around. So let's just go over the accessories that I got to do this LED project. So I have the Meanwell LPV 112, and this will go from AC voltage to DC voltage, and that will essentially go to this Zigbee dual white LED controller, which takes in that voltage and outputs to the cob LED strips. So you have WW, CW, and then you have two V+ outputs. Each one can do up to 7.5 amps per channel. And then we have just a enclosure that I'm going to put both of these in, and this is just going to go diagonally. And since this is so tiny, I'm going to kind of put it in there like that. And then we have some LED strip connectors. So basically these support both 3-pin and 4-pin cob LED strips. And I'll show you these open. So you can see these sort of just solderless connections attached to the 3 pins. And you can insert the wire that they included or your own wire depending on the thickness of the gauge. What I did end up keeping is these quick disconnects, which are 18 gauge. You can see we have the female and the male. So going forward in the video, when you see a quick disconnect, just keep in mind that I end up using these in the end. And then we have some of these Wago 221413s, which will split on this dual white LED controller. We're going to split the WW into two different sides, so left side of the kitchen, right side of the kitchen. And so you can see I run a wire into one of these. So WW will go in here and then split between the two of them. And same thing with CW, and then I will not need that since there's two different channels for those. And then we have the LED called CCT LED strips themselves. These are 12 volt. So this is what comes in the bag. So this is 16 feet of strip, and I'm going to cut this into one side of the kitchen and the other side. So this should be just enough, but honestly I might run out. And they also include a convenient connector here, a mount with some solderless connections, just like the extra ones I ordered. And then I had to get a huge pack of these, which I didn't want, but this basically helps with my larger gauge to smaller gauge wire. So these levers, you can stick in a smaller gauge wire into one side and a larger gauge wire into the other, and it'll connect the two of them, or same gauge, whatever. It just will be easy if we do need them for this project. And then we have our wire here that I'm going to be running to a different room. So I have 14 gauge wire that has 3 wires inside. So we have the WW, the CW, and the V positive. This is sort of thick. Unfortunately, I'm doing a run that is sort of over 20-25 feet. For me to run this without getting a lot of voltage drop, I needed a thicker gauge wire. I also got this Hun aluminum channel kit, which is basically a bunch of lengths of aluminum channels that I'll just cut to fit basically underneath the cabinet, between, you know, here and there and so forth. This comes with covers, like milky covers, so it diffuses the light properly. It also comes with some adapters to mount underneath the cabinet with some screws and stuff. And yeah, basically I'm gonna have these sitting in those aluminum channels that have a diffuser on them. I also got this 8-foot replacement cord that we can use to hook up to the Meanwell PSU. I also have this fuse that I'm gonna put, and I had this before, and I'm just gonna strip it and throw in a 10 amp fuse in here just to be safe. So first I'm gonna screw this down to the base and screw this down to the base, or zip tie it. And I'm also gonna trim these wires because they're a little long. Okay, so I ended up screwing this one down with some washers, and it pokes a little bit out of the bottom, but it doesn't hit the bottom. And then I ended up widening these holes and zip tying this one. It took a lot more effort than it really needed to be. Now I'll hook this up with the fuse and shorten these cables. All right, so we got the power supply mounted and the Zigbee controller mounted. This is ready to attach to the cord. These, and I don't need 3, but that's just what I had. And we have the fuse in line from the power supply to the Zigbee. Then I made some holes, one for the cord to go out of on this side, the other way to go for the LEDs on this side. This will just fit right in there like that. So now I attached 3 cables to the Zigbee controller. So we have the WW, CW, V+, and V+. And so now we'll connect the regular cable, regular extension cord to this, and then we'll test out the LED strip connecting to these 3. So I have the cable wired up to those 2, neutral and line. And now I'm gonna take the strip, and I'm just gonna strip these 3 wires and hook them up here and see how this looks. All right, so I cut off the end of this and wired up each wire according to the strip, 12 volt CW, WW, and attached them to each 3 of these. And we got the cable plugged in. And there we go. So I ended up picking up some of these Wago 221412s, which is the same thing I already had, but just for 2. So I went back in here. I just redid some of the wires that I only had 2, like this one, and the one that's gonna go to the AC current, and then like the power, the V+ for one side, and then the V+ for the other side, and then I'll keep these on 3s. The next thing I did was run the cord from the room where I'm going to actually have the brick that I keep showing below this room. So I drilled a hole here, obviously messed that up here. There's a stud like literally right here. Drilled a hole here, went down the wall into the room below. And that's where one end will go through one of these sides. So each side's going to go in here, and it'll wire up to the end of this. Alright, so next I fed the power cable for the AC voltage into the box and put it with my two Wagos here. And so now I can basically put this box down into the room that I'm running the wire to. Alright, so I got the box down here in this room where the rest of the server stuff in my other video is. And I'm thinking about putting it here, maybe on this wall. And you can see I have the cable coming down from the wall alongside, which is not easy. So I can just run this right into one of these ports in the box. This should be ready to go. So next what I'm gonna do here is I'm gonna measure from here to here and get a similar length on the LED strip, because what I wanna do is I wanna test just having one strip here, then eventually we'll cut the aluminum channels as well. But I do wanna cut on these portions and sort of line up what the best inch difference will be compared to the cabinet. And I do have these solderless connectors, which I was just looking at, and there's two different types of adapters here. One of them you just slip the LED strip in. Some of them take both LED strips on both sides. Another one they have in here, you can push in the cables, you can see on that side, and then on the other side you can slip in the LED strip. So I'm going to do that with a strip here and then just sort of practice on two different sections here, because there'll be, as you can see, one section here before I try and go up here. So I just measured the cabinet and it is 22.5 inches, and 22.5 inches does line right up with one of these contacts. However, this is going to be right at the edge and that's going to be right at the edge. So what I'm going to do is actually bring it down to this one, and what are we at now? 21.5 inches. So that gives us, like, you know, half an inch on both sides. So I'm gonna go ahead and cut that piece. So I cut the length and we have the wire on one end and the slide in LED strip on the other end. So I'm gonna take this and basically slide it right in. All right, so I slid it right in. You can see the contacts will hit when you push them down, and then I'm gonna put the wires in. All right, so I slid the wire in. I got the red on the 12 volt, and then the green on the CW, and the black on the WW. Now I'm gonna take some pliers, and it's gonna push it down. I gave it a good push on both sides individually, and you can see here they're down. Now let's try and get it connected up to another one. So the next one is 33.5 inches, but this time I'm actually gonna cut off 2 inches based on putting this up into the cabinet, and just for convenience I'm gonna cut right on this one. So I'm gonna take another one of these with the wire on one side and put it on my other end here, and I actually took the extra wire off that comes with this because it comes with 4 wires. And I'm gonna make sure and do it on the right side where this continues. All right, so we got 2 strands here, and I plugged it up to the wires, and then let's test this out downstairs. The cable is connected, and these two are swapped, so I'll have to fix that upstairs when I'm actually done installing. Now we can go ahead and plug this in and test it out. So we got it plugged in downstairs, and you can see the strip is working. And this is where I swapped them, so I could easily just swap these two. So I'm pretty happy with this second length here. So when I hold it up to the counter, there's an adequate amount of length for this end to reach this connector through the cabinet, and there's an adequate amount of length on this side for the wires to go into the wall, and then hopefully we can come out right up here. So I'm going to go ahead and throw a connector on this. Okay, so I added on the connector to this, and then I put it into this 3-prong connector because when it gets to here, I'm going to go into the wall with a 14 gauge wire. So I'm just simulating this going right into another connector here, which is going to go above the sink, and it's going to go back into one of these, and then back in the wall, and then back into these 2 sections here. So let's just go test this completion. All right, so we got the other strip working, and that's good. So now I'm going to do the other 2 sections here, and then at that point, hopefully we can start thinking about the aluminum channels. Okay, so we have all the sections hooked up, ignore the sink, and let's go test this now that the whole strip is connected. All right, whole strip's connected, illuminated. So that's good. Now we can figure out these aluminum channels. I'm gonna take down the measurements of each one of these strips, and I'm gonna write them down on the sheet. And we got all the channels here, and I'm gonna go outside and cut them. So use the miter saw, got our 5 cuts here, and I actually got lucky with the leftover. It's exactly the length I needed. So I have my 5 cuts here. I'm just gonna use some of this alcohol to clean each channel so that the LED can be adhesive really well. So at the bottom of these strips, this blue tape, I'm gonna take this off, and I'm just gonna push it down on the channel. All right, so I got one down, press into the channel. I did make the mistake of putting these on. I'm not sure what I would have done instead here, but on this one, for example, I have the blue tape going into each side, so I'm just gonna try and pry it off and do the other channel here, and then I'll do all the other ones as well. Got them all in their channels now. Got the first one, second one, the one above the sink with the 2 disconnects, and then the 4th one and the 5th one going into the original cable. So next what I did is I added these mounts that come with them, and they just snap into place. And I take basically these screws, drill them into the cabinet, and I put 2 on each. I think for now, what I'm gonna do is put on some 3M tabs, because my issue is the front of this cabinet is like 1.5 inches or so. So I wanna find a good placement, whether it's 2 inches back or 3 inches back, so it doesn't cast a shadow. So temporarily putting on 3M tabs and sort of just testing out this area, I think will be a good choice for now. And then I can also trim these, put on maybe some white heat shrink that I can find, and sort of adjust, you know, push this back in the cabinet. Instead of keeping this, maybe I'll just convert it to directly attaching these wires together. Let's just put up this strip for now and see how it is. So I put them up with the 3M tabs temporarily, testing out roughly 2 inches. You can see that this wire sticks out here. So it'll be good to shorten this. And let's see how this area looks. There's how it's looking. Exciting. See how it looks with the lights off. I also noticed there's a little bit of strain here on the end, and I don't have the covers on yet. But if I go over here and take one of the covers on, luckily when I go to press this in, it actually does fit with that in there. So that'll be good. So maybe for now, I'll actually cut these and see if I can just cut them with my 10 snips without needing to drag out the miter saw again. So these actually did work great. I ended up cutting and putting on the channels for these ones that were already up here. I think it helped diffuse the light more, especially with the shade coming from the front of the cabinet and things like that. So the next thing is coming from this light strand here up to above the sink, and then coming back down to this light strand here. And I'm using my 14 gauge wire in between because I want to minimize the voltage drop. So I was able to make a hole here and fish it up to here. Luckily I had access to the back wall here and then back down here. So then we'll be able to connect 1, 2, 3. So I stripped all these back. I'll just leave a little bit of the plastic on here, and then I'm hoping to cover this with white heat shrink to blend in with the cabinet. So I got all these, and then I got this one hooked up to the currently mounted LED strip. So we're just gonna test this out. So I'm gonna mount this one and these 2, and then see how it goes. So we got one under here, one under here, connected here, up here, connected to this one, down, back over here to the first 2, and then down to the board. So let's test it out. All right, there we go. That's all connected. Definitely have to clean up this on all those connectors, get some white heat shrink, figure out what I'm gonna do about this. Honestly, I think that it would have been better to just cut out an opening here and have one long strip. I might just have to strip this and put some white heat shrink on it or something. But I'm excited. So I was having an issue with the section after this, and I noticed this connector was messed up. So I ended up ripping this off here, and you clearly can't reuse it because it was just so damaged there. So I'm gonna have to just trim back to this next one. But on the bright side, I did get to run this through here, and I got some heat shrink tubing that's white, and so I'll probably put that on there and redo this connection. Cool, so this is all working just as expected now. I put some heat shrink on there and ran the wire through there. We lost like small section, but oh well. If I wanted to redo it, I would have to get a whole new strip there. So obviously I don't want to leave this here, and I want to tuck it up in here, but these are just a little more bulky than I originally thought when I ordered them. So I ended up getting some of these butt splice insulated connectors, 16 to 14 gauge. So I'm gonna put the 14 gauge wire in one end, and then the smaller gauged wire, which is more like a 20 gauge or maybe even 22. I'm gonna strip this back and then fold it over, put one of these on, and then hopefully I can take some of this larger heat shrink tubing and just clean up this entirely, and we'll see how that goes. I did end up making a hole here, which should be able to fit this portion through, so I don't have to splice these wires. So it should be able to come out. Not the prettiest, but oh well. So this heat shrink tubing works for the small cables like this. If I put them on beforehand, these will not fit 3 of these cables with these butt splices in them. So I ended up ordering some thicker heat shrink tubing. This is 3/4. I also ordered some BTF lighting connectors, which are the same thing that come on the LED strip. So these are the connectors, and you can get 4-pin, 2-pin, 3-pin. So I got the 3-pin for the cob strip. So if I was, when I do the right side of the cabinet, I'm gonna actually redo the LEDs in a different way. So I'm gonna actually put one of these at one end and one of these at another end, so that you can easily connect up to another LED without me manually, trimming the cables like up here. So I'm gonna actually take this, and when I go for my 14 gauge wire, I'm gonna go down to this size so that this can go right into the LED strip, because I don't wanna leave these bulky connectors on all 4 places here, or 5 actually at the beginning too. And just to show you what I'm doing here, I stripped back this a little more because the initial gauge is definitely even smaller than what's in the wire that comes out. So I stripped it a little more, I folded it in half, put it in the butt splice, crimped it down, and then these will go on the other ends of there. So here are the cables. You can see when they're all together, it won't fit in the heat shrink that I had, so I got the larger heat shrink. So now I'll put the heat shrink on this, and then I'll have to take down both of these lights, put on the opposite connector here. Here is the connector with the heat shrink tubing on there. Probably should have put smaller heat shrink on this side before I did this and whatever. I'm gonna redo this because I don't want to put more butt connectors on here. I just want to go straight onto the strip. So I'm just gonna lose out on this like inch of strip, cut it here, and then put the connector piece straight onto the LED strip the way it's meant to be done. That looks so much better, and then this can actually hide right at the end, and it'll come right out to the female end of this. Now it's tucked right up in there, convenient unplug, and if I have to redo this LED strip for some reason, I can just easily plug it up. Now just to do these other ones. I ended up taking down the light, and I ended up redoing this. I cut the ends off. It's just gonna be so much cleaner like this, and it'll be so much more flush from end to end. And then here's a look at just a short transition from these splices to the 14 gauge, and then a little bit of heat shrink here, and it'll go right into the light. If you look at above the sink now, you can see so much cleaner, heat shrinked. This could probably be like stapled up or something, Same thing on this side. Also just gotta, stable this up. So here's how it's looking right now. The left side is pretty much done. I switched this over to a quick connector, switch this up to here, up there, there. The only thing that I have to do is just fix that cabinet piece there when I drilled the hole and just sort of secure the wiring, and then maybe wrap the sections that transfer from heat shrink to heat shrink with like white electrical tape. The left side is pretty much done. So here's how it's looking right now. The left side is pretty much done. I switched this over to a quick connector, switch this up to here, up there, there. So the next thing I did was I mounted the box in the basement on the wall, and you can see it's all set up here. I changed the fuse in here to a 10 amp fuse, which is now more appropriate for this circuit. Here you can see the left side of the kitchen is plugged in and going up to the kitchen, and now I can just close this and add in the right hand side next. I also ended up finding these mount bases at Home Depot, and they're super thin and you can use zip ties on them. So I'm going to use these to adhere the wires to the side of the cabinet, and that's exactly what I needed. Starting on the other side of the kitchen, I moved the fridge back and was able to gain access behind the fridge, down into the basement, and I'm going to run it to the original power module over there. And then we have our next LED strip, and we'll get this connected up with another quick connect on those 18 gauge quick connects. To get to the other side from this countertop, going back in the wall, down, I took some drywall out to get through, over, and then we'll get to this other side. And then I'll put a panel in here for access, put the drywall back, and put the stove back. Close this back up. I'm gonna spackle and sand these pieces that I put back in. And I have an access panel here, and then mark some stuff I wanted to know what was behind there. And then I have the wire here for here, and it's ready to go for the other LED. Got the other side hooked up here now. Now I'll just need to do some heat shrinking. I have the new line hooked up right here into the new connection for another power, and the data lines, and then we have just it feeding back to the other side of the kitchen. So at this point in time, the kitchen is fully working. I have the lights set up to the controller box in the basement. All the wiring is done. But unfortunately, I ran into an issue of very subtle flickering. Now, I didn't get this on video, and it was really hard to tell unless you were standing right at the sink. But basically, everything after the first disconnect was just dim and not the same. So what I figured out was there was not enough power getting along, and I needed to swap out the disconnect. So I actually had to go back and swap out every single disconnect that I had, which were the 20 to 22 gauge quick connectors with 18 gauge soldered connections. So I did end up having to solder, which I was hoping not to, and everybody is usually like hoping that they won't have to for something like this. But I did end up doing it. I just had a little practice on a couple different LED strips, and once I got the hang of it, it really wasn't that big of a deal. So I would highly recommend using those 18 gauge 3-prong disconnects. They were perfect for my use case. They've been working now for months, and they ended up being the resolution for the issue. And it was driving me crazy because it was during the holidays and I wanted to just get this project done. So once I did go back and get all the disconnects and the LEDs sorted out with that voltage issue, I went back and added all the heat shrink I needed to, and now it's at a good spot where I'm happy, and it's been working great for months. So now that it's been working great, I have it tied into Home Assistant with the Zigbee capability that the controller has. So when you walk into the kitchen area, the lights come on automatically and illuminate the area without the need for turning anything on and off manually. Same thing with turning it off. Eventually it'll just go off on its own after certain requirements with the automation I set up. So let's take a look at the price breakdown of everything I ended up using. So for the enclosure that I ended up using, some of them ended up getting pretty pricey. This one I ended up using was $20. I have a link with the dimensions down in the description. The Zigbee controller was $22, which controls the cob strips for color temperature and brightness and Zigbee. All the connectors I ended up using, $13 for the 18 gauge 3-pin quick disconnects, $7 for a pack of the 3-wire WAGO connectors, $8 for a pack of 2-wire WAGO connectors, $20 for white heat shrink, $30 for 30 feet of the 14 gauge 3-wire, $20 for the 16.4 feet of cob LED strips, $25 for the power supply, and $28 for the 33 feet of aluminum channel. And I didn't end up keeping the 3-pin quick connectors that I labeled in the beginning, the solderless 10mm LED connectors, and the 3-wire lever connectors because they were too bulky. So in total, it did end up costing around $200, give or take, with buying more heat shrink and buying a new spool of LED because I had to redo some of those. Overall, it ended up being much cheaper than the 120 volt undercabinet lighting with a lot more customization. So some lessons learned. If you're doing a more elaborate run like this, I would definitely just solder from the get-go. I would use the 18 gauge quick connects again. They worked great for my use case. If you are having a simple run of just one strip of LED like I've done in a few other videos and like I'm planning on doing with my shed project, you could definitely get away with those quick disconnects and the quick connectors on the LED strip. The highest gauge I would end up soldering was 18 gauge. I couldn't find any convenient connectors that you could just push the wire in and screw it down or anything like that, so solder was the way to go in this application. Definitely buy more heat shrink than you need. I ended up needing to order 1 or 2 amounts more than I thought I would end up having, and I'll definitely be using the WAGO connectors going forward because they're just so convenient. So I hope this helps give you a breakdown of everything I needed to do this project. I've been meaning to settle this project out for months now. I started on it earlier in the holiday season, and now it's about May. I've been meaning to close out this video for a while now with the breakdowns and lessons learned and talking about what happened after I finished all of it. So I hope this helps anybody looking to do the same thing. Let me know if you have any questions. I tried to share everything that I ended up doing on the project for anybody else looking to do the same. So I hope this helps somebody else, and thanks for watching.